Hi there, this is Courtney and Emmy, and this is our homework for ENGI460. So the problem we're looking at is that we have a square unit, so it has a unit of 1 on each side, and then we have 2 points, A and B, that are randomly selected within that unit, and they have a distance D. So our problem is to use Monte Carlo to estimate the expected distance and then the variance of that distance, and then to plot that distribution of the distance. And so then part C is to suggest a more efficient method for estimating that the probability of D is greater than 1.4. And the reason why we're doing this is because using Monte Carlo, it's such a small probability that it would be really ineffective to do Monte Carlo because you would need like way too many iterations to even get close. So it's just super improbable. And so for our code, basically what we're doing is that we have x1, x2, y1, and y2, and we're just generating random numbers from 1 to 50,000. That's what our n equals. And so then we're plugging these values here into just regular distance formula right there. And then here's our code to get that expected D and the variance of D. So it's just the mean and the standard deviation. Then for part B is just to graph the histogram of that. So for our expected our expected D, it's 0.5229, and our variance is 0.0617, and then this is our lovely histogram.
So part C asks, can we find 2 points that are a bit easier on the unit square that are the max length, the probability of the max length being greater than 1.4. Now we know in the unit square, the diagonal is the square root of 2, which is approximately 1.41421. So we're using Monte Carlo. This is going to be very tedious and misleading if you end up finding at least one point that spans the distance greater than 1.4 on the unit circle. So there are a few ways to, I guess, kind of approach this problem. Instead of using simulations, you can use just areas, because eventually Monte Carlo will use areas to determine probabilities using simulations. But we can figure out the areas by dividing up the quadrants of the unit circle and creating a circle of radius 1.4 at the center. And because we know then the formula for that circle, we can find an intersection between the unit square and that circle, which means we can now use integral calculus to find an area between the curves. That area between the curves really can be divided over the total area in the unit square. And because you want them to be in opposite corners, you would divide them by 2 to give us an estimated probability. And the probability of them being in opposite corners, you'd have to do probability of one corner union probability of another corner. Now dividing by 2 gives you some linear dependency in this problem, so you'd probably have to do it in permutations of each corner of the probability of having in each corner. But that is one way of trying to find an easier method for finding a distance greater than 1.4.